Okay, dear students, let's see the next question. So what is the concentrations of this solution which contains 6.02 into 10 to the power 20 molecules of urea in 100 ml of its solution? So in this case is the formula of urea is H2CONH2. So if you calculate the molar mass, we'll get 60 gram per mole. Okay, so we know that 60 gram of urea equals to 6.02 into 10 to the power 23 molecules in terms of molecules. That means 6.02 into 10 to the power 20 molecules. How much gram of urea? That is x gram of urea. So x gram of urea equals to 60 into 6.02 into 10 to the power 20 divided by 6.02 into 10 to the power 23 molecules. So cancel. So it will be 60 into 10 to the power 20 minus 23, 10 to the power minus 3 gram. Okay, so in terms of moles of urea equals to given weight by molar mass. Weight is 60 into 10 to the power minus 3 gram by 60 gram per mole. So we'll cancel this 10 to the power 3 mole only. Then after molarity is equals to number of moles of solute divided by volume of solution in liter. So volume is already given, that is volume is 100 ml or it is 0.1 liter or 10 to the power minus 1. We can write like this also. So molarity will be 10 to the power minus 3 mole divided by 10 to the power minus 1 liter, minus 3 plus 1 mole per liter. So it will be 10 to the power minus 2 m, which means 0.01 m. So option B is the right answer. Okay, dear students, let us see this question. 10 gram of hydrogen and 64 gram of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be. So first of all, we have to write the equation. That is H2 plus O2 is going to give water. So to balance this, write this 2. So in this case is 2 mole of hydrogen is reacting with 1 mole of oxygen to give 2 mole of water molecule. Since in this case is 10 gram of hydrogen and 64 gram of oxygen it is given there. So moles will be 10 by 2 and 64 by 32, which means 5 mole and 2 mole. So in this cases it will be x mole. Okay, so 1 mole of oxygen uses to give 2 mole of water. That means 2 mole of oxygen uses to give 4 mole of water, because one mole of oxygen is given 2 mole, then 2 mole will give obviously the double of that, 2 moles. That's so it will be 4 moles of water. So hence option will be C. Okay, we need to find the moles of lead chloride which is formed when the 6.5 gram of PbO and 3.2 gram of HCl is reacted. The solution will be PbO plus HCl to give PbCl2 plus H2O. So 1 mole, 2 mole, 1 mole, 1 mole. So 6.5 gram divided by 223.2. The molar mass of PbO is 3.2 gram, and it will be 3.2 divided by 36.5. The moles we found is 0.091 and 0.0877. Okay, so the moles will be since you know that Pb is the limiting reagent, the product depends on the PbO, so that's why the product will also be 0.021. Okay, so option D is the right one. Okay, we will see the next question. What volume of oxygen gas measured at 0 degrees Celsius and 1 atmosphere is needed to burn completely 1 liter of propane gas measured under the same condition? So we are burning the propane. So propane is been burnt. If you burn this, you will get carbon dioxide and water vapor. So to balance this one, we'll write 3 here. So 3, then hydrogen each 8, so 6, so 5 molecule will be there. So 1 mole, 5 mole, 3 mole, 4 mole. So if I write this in the liter, it will be 22.4 4 into 22.4. So if I am burning 1 liter of gas, propane gas, then the oxygen used is x liter. So the value of x will be 5 into 22.4 into 1 divided by 22.4, which is equals to 5 liter. So option will be C. Okay, dear students, let us see the next question. So for this question, number of moles of MnO4 minus required to oxidize 1 mole of ferrous oxalate completely in the acidic medium. So you should know basically the reactions, you should know. That is very important. Then only you can able to calculate the numericals part on. So the equation will be 3MnO4 minus plus 5FeC2O4 plus 24H plus will give 3Mn2 plus 10CO2 plus 5Fe3 plus and 12H2. So this is basically the reactions which happen with the permanganate with the ferrous oxalate. So here you know that 5 mole of Fe2 plus uses 3 mole of MnO4. Why I am writing Fe2 plus? Because the ferrous has been oxidized to the ferric part by the permanganate ion. So 5 mole of ferrous ion has been uses 3 mole of MnO4. So if 1 mole of Fe2 uses X mole of MnO4 minus, so X will be 3 by 5, which is 0.6 mole. So hence option is A. Okay, dear student, let us see these questions. In this question, generally the bauxite means bauxite is the ore of aluminium, and Hall and Harrell process is there. This process is generally used for the productions of the aluminium metal. So the question is, that is, to produce 270 kg of aluminium metal, how much carbon has been consumed? So for that, write the chemical equations involved for the productions of the aluminium. So aluminium oxide is reacted with the carbon anode to give aluminium and carbon dioxide. So to balance this, we will write like this. So 2 mole of aluminium reacted with the 3 mole of carbon to give 4 mole of aluminium. So basically these two are important, carbon and the aluminium. So we will consider this one only and convert them into the kilogram. So it is 36 gram. So it is in the kilogram, 0036 kilogram. Similarly, 4 into 27 will be 108 gram, and in kilogram it will be 0.108 kg. So for the production of 270 kg of aluminium, how much carbon has been consumed? So X kg. So X is equals to 0.036 into 270 divided by, which is equals to 90 kg. So option D. Okay, let us see the next question. Here we have to find out the composition of gaseous mixes under the opposite condition in the end. That is the Haber process, which is given here. 30 L of dihydrogen and 30 L of dinitrogen were taken for the reaction, which yielded only 50% of the expected product. So what will be the composition of gaseous mixers under the aforesaid condition? So in this cases, let's see first the reaction of hydrogen and dinitrogen. Your Haber process is generally used for the production of ammonia. So in these cases, we used to react the hydrogen with the nitrogens to give ammonia. So to balance this one, we'll write this one. So it is 3 liter. In terms of liter, it is 3 liter, 1 liter and 2 liter. So if I consider the dihydrogen as 30 liter and it became 10 liter, so it became 20 liter. The production of ammonia will be 10 liter. So 50% is only the expected product. product, which means 30 means it is 15 liter only, 10 means 5 liter only, and 20 means 10 liter only. So as per the given conditions, that is 30 liter of dihydrogen it is. So 30 minus 15 means it is 15 liter only, and nitrogen, dinitrogen is 30 minus 5, which is equals to 25 liter, and the product will remain same, that is 10 liter. So the answer will be 15 liter of 15 liter of hydrogen, 25 liter of nitrogen, and 10 liter of ammonia. So to match this one, the answer will be option D. So correct option is D. Okay, my dear student, let's see the next question. Here, which one will be the right options for this given reaction? When 1 mole of ammonia and 1 mole of oxygen are made to react to completion. So equation is 4NH3 plus 5O2 to give 4NO plus 6H2O. So we have 4 options. 1.0 of H2 is produced, 1.0 NO will produce, all the oxygen will be consumed, all the ammonia will be consumed. Let's see one by one. Here we have moles ratio of NH3 and O2 is 4:5. So 1 mole of NH3, the required O2 is 5/4 into 1, which is 1.25 moles. That means the option 1 which is given here, 1.0 of H2 is produced, 1.0 of NO will produced. Okay, dear student, let us see the next question. We need to find out the number of moles of KMnO4 that will be needed to react with 1 mole of sulfide ion. So let us derive the equation. So MnO4 minus ionic form, sulfide means SO32 minus, that is MnO4 will convert it into the Mn2 plus and sulfide into sulfate. So this is the equations. To balance this one, we will take the individual ion half cell reaction. Here plus 7 oxidation state it is there, which is Mn2 plus. So 7 minus 2 will be 5 electron differences is there. To balance this oxygen, we'll add water here. So 4 molecule of water it is there. So and hydrogen is 8. Now after that, sulfide ion, which is converted into the sulfate ion. Here we have 3 to the 6. 6 minus 4 will 2 minus 4 will be there. It is 6. The differences is 2 electron. And to balance this, we'll write the water. So 4 molecule of water. So you will write here 2H plus. Now the electrons are not balanced. We'll write 2 here and you will write 5. So after balancing, we'll get this 2 cancel. 2 5 is 10, 2 5 is 10. So it will be 10 10 will be cancelled. You know that hydrogen became 2 8 16. Here 5 is a 10. So 10 and 16 it is there. So cancel, it will be 6 only. And water is 5 is there and 8 it is there. So 5 will cancel. 3 will be remaining. So 2 MnO4 minus 5 SO3 2 minus 6H plus will give 2 Mn2 plus 5SO4 2 minus 3H2. So this is the overall reaction in the. So we need to find out the number of MnO4 minus utilized to 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 react with the SO3 2 minus. Here 2 mole of MnO4 minus uses the 5 mole of SO3 2 minus, means X mole of MnO4 minus uses 1 mole of SO3 2 minus as per the question. Then after, the value of X is 2 by 5. So option will be B. Okay, dear student, let us see this question. So we need to find out the volume of the carbon dioxide released on heating 9.85 gram of BaCO3. So BaCO3 decomposes to give BaO plus CO2. One mole of BaCO3 gives 1 mole of BaO and 1 mole of carbon dioxide. So if I convert that into the moles, BaCO3 9.85 given weight by molar mass will be 197, which is equals to 0.05 mole. Okay, so 0.05 mole is giving X mole. So X is equals to 0.05 mole into 1 mole divided by 1 mole. Cancel, X will be 0.05 mole. So moles of carbon dioxide is also equal to 0.05 mole. Now then after, we know that 1 mole of CO2 equals to 22.4 liter. So 0.05 mole of CO2 equals to X liter. So X is equals to 22.4 liter into 0.05 mole divided by 1 mole. Cancel. So it is going to give 1.12 liter. Hence option A. Okay, dear students, let us see the next question. The number of moles of KMnO4 reduced by 1 mole of Ki in alkaline medium each. For this reaction, we need to see that there is 2 possibilities are there. One is KMnO4 is converted into K2MnO4, or either KMnO4 is converted into MnO2. So there is 2 possibilities are there. So let's see one by one. Let's see the second one will do. This one is 1 and this one is 2. Let's see the number 2. In the number 2, we will see that MnO4 minus reacted with the I minus to give MnO2 plus IO3. So half cell reaction will be plus, this is 7 and it is going to give a 2, so 4 differences of 3 electron. And since it is taking in the basic medium OH, it is there, we'll add water. So to balance this one, let's say 2H2 water, so it will be 4OH. Then another one is the I1, it's converted into IO3 minus. So this is -1, this is 5, so there is a differences of 6 electron it is there. And in the basic medium, we will write here water also, so 3 molecular water 6, so if I write here 6OH, so 6 electron it is there, 3 electron it is there, multiply with the 2, so it became 8, it becomes 6, so here 2, the 6 and 6 will be cancelled, water will be the 2 to the 4 and 3 it is there, so 1 will be there, so 2MnO4 minus I minus plus H2O to give 2MnO2 plus IO3 minus 2HO minus. So here we know that 2 mole of MnO4 uses 2 mole of OH minus ion. Therefore 1 mole of OH uses 2 by 2, which is 1 mole. So this is the one way. This will also give the option C. And for the first one, that is KMnO4 converted into the K2MnO4. Usually this reaction is not possible, but under control condition it is possible, so we'll consider that one also. Under control condition, the equation can be written like this: KMnO4 plus Ki plus KOH is going to give K2MnO4 plus KiO3 plus H2O. So to balance this one, multiply with this 2 and 2. So under control conditions also, 2 mole of KMnO4 is using 2 mole of KOH. So for 1 mole of KOH will be X mole, so X will be 2 by 2, which is 1 mole. That is option C. So in both the cases we'll get the option C as the right answer. Okay, my dear students, let's see the next question. Here we need to find out the right option for the reactions of 1 mole of ammonia and 1 mole of oxygen. Let's compare one by one. First of all, let's write the reaction. So in this case is moles ratio of NH3 and O2 is 4:5. So 1 mole of NH3, the required oxygen is 5/4 into 1, which is 1.25 moles. Similarly, for 1 mole of O2, the required NH3 is 4/5 into 1, which is 0.8 moles. Okay. Then 1 mole of O2 is lesser than 1 mole of NH3. Hence, O2 is limiting reagent. That means the reaction depends on the amount of oxygen. And let's see the option A, B, C, D are right or not. 5 moles of oxygen produces 4 moles of NO. So mole of O2 produces equals to 4/5 into 1, is equals to 0.8 moles of NO. So if you see this option A, B, C, D, B is having 1.0 mole of NO will be 1.0 mole of NO which has been produced, but it is 0.8 only. So B is incorrect. Similarly, 5 moles of oxygen produces 6 moles of water. So mole of oxygen produces 6/5 into 1.2 moles of H2O. So it is 1.2 is given. Option A is 1.0 only, the mole which has been produced. So option A is also incorrect one. Then 5 moles of O2 consume 4 mole of NH3, because oxygen is 1 mole lesser than the ammonia. Hence, so 1 mole of O2 consumes is 4/5, which is equals to 0.8 moles of NH3. Hence, all oxygen is consumed during the reaction. Hence, option C is the correct one. Okay, dear students, we'll see this question. Equal masses of H2, O2 and methane have taken in a container of volume V at temperature 27 degrees Celsius in the identical condition. The ratio of volumes of gases H2, O2, methane would be 8:16:1, 16:8:1, 16 ratio 1 ratio 2 and 8 ratio 1 is to 2. So we will see this solution. This ratio is given and we need to find out the ratios of its volume. We know that the mass of hydrogen it's 2, it's 32, and methane is 16. So if I cross this one, so it is coming as 1 ratio 16 ratio 8. So in terms of moles, we will take this one, the ratio of 1, 16, 8, 16. So 16, 16 by 16, 8 by 16. So it is 16 and 1 by 2, which means 16 ratio 1 ratio 2. So our answer is C. (16 1 2), which mixed with 11.2 liters of Cl2 each at STP. The moles of HCl formed is equal to. Now see, during this reaction, H2 react with Cl2 will give 2 HCl, which means 22.4 liter of H2 react with 22.4 liter of Cl to give 2 into 22.4 liter of HCl. Since we know that only 11.2 of Cl2 is reacting, since if it is 22.4 liter and it is 11.2, that means Cl2 is a limiting reagent, so the product depends on Cl2 only. So if 22.4 liter is giving 2 into 22.4, then 11.2 will give 22.4 liter only. So it is 1 mole of HCl. Hence option will be A. Dear student, let's see this question. Here we need to find out the exact formula of chloride, and the options are given here. So let us see first the millimoles of chloride, which is 10 ml of 0.05 m, which means 10 into 0.05, so it became 0.5. Similarly, if we see the millimoles of AgNO3, it is 10 ml of 0.1 m, which means 10 into 0.1, so it is 1. Now if you see the millimoles of AgNO3 with respect to the chlorides, it is double of that chlorides, so that's why the charge of X must be 1 by 2, 0.5, which is 2. Therefore the reaction be like this: HCl2 give so option is B. Okay, dear student, let's see the next question. That is, number of atom in 4.25 gram of NH3 each approximately. So the formula is number of atoms is equals to given weight by molar mass into Avogadro number into atomicity. So it is 4.25 gram divided by 17 gram per mole into 6.023 into 10 to the power 23 all inverse into atomicity is, since there is NH3, 3 H is there and 1 nitrogen is there, so it is 4. So this mole cancel, so altogether we'll get so option is D. Okay, dear student, let's see this question. What we have to find out, we have to find out the molar concentration of sodium ion and carbonate ion, and let's see the solution. So the molar mass of Na2CO3 will be 2 into 23 plus 12 plus 16 into 3, so it will be altogether 106 gram per mole. So molar mass of Na2CO3 will be 106 gram per mole. So moles will be given weight by molar mass, which is equals to 25.3 gram is given the mass of sodium carbonate, and the molar mass is 106 gram per mole. So if we calculate, we will get 0.2387 moles. Now we need to find out the molarity. Molarity is equals to number of moles of solute divided by volume of solution in liter. So 0.2387 moles, and volume is 250 ml, which means 0.25 liter will give 0.955 m. So if we see Na2CO3, it is 2Na plus and CO3 2 minus. Then concentration of NaN will be 2 into 0.955, which is equals to 1.91 m, and the concentration of carbonate is 0.955, which equals to 0.955 m. So the option will be B. Okay, dear student, let's see this question. Among all the options given, which one is the right one? let's say let's calculate the charge of each copper and CD in each of these complexes. 2 plus x, so x minus 2 is equals to 0, so x is equals to 2. So it is stable. B is so this one is also stable. And C K3 this is less stable. Two plus x plus 3 into minus 1 is equals to 0. So x minus 1 is equals to 0, so x is equals to 1. So if we see all this option, the correct answer is C, because minus 1 cannot be the charge, so that's why it is less stable. Okay, dear student, let's see among all of this given option which is not a paramagnetic. So any 2 plus means 10 minus 2, which is equals to 8. So electronic configuration will be 1s2, 2s2, 2px, 2py1, 2pz1. It's paramagnetic. B is Be plus, the value of Be is 4, 3. So it's the electronic configuration will be 1s2, 2s1. So it is also paramagnetic. C is Cl minus 17 minus 17 1 plus, which is 18. 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz2. So this is not paramagnetic. D is As minus. So As is how much? 33 plus 1, it is 34. So electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4px1, 4py1. So it is also paramagnetic. So our option is see. Okay, dear student, let's see the next question. We need to find out the normality of the solutions. So since here the value is given in the molarity, but we have to find out that in the molarity. So formula will be N1B1 is equals to N2V2. So 5 molar M1 is given 5M. So N1 will be M into N factor. So you know that N factor for the H2SO4 will be 2. So N1 is equals to 5 into 2, which is equals to 10N. So 10N into 1 is equals to N2 into 10. So this 10 cancel, 1N. So the option is option A. Okay, dear student, let's see next question, that is 0.24 gram of volatile gas on open vaporization gives 45 ml vapor at NTP. What will be the vapor density of the substances? The density of H2 is given here. So weight of gas is also given here. So weight of gas is gram is given here. Volume, which is given here as 0.045 liter, and density is 0.089. Now density into volume equals to mass. So mass will be into 0.05 liter equals to 4.005 into 10 to the power minus 3 gram. Now vapor density is equals to weight of certain volume of substance divided by weight of same volume of hydrogen. So now this is applicable when the given condition is at the NTP, normal temperature pressure, because on the same temperature and pressure the weight of the certain volume of substance is divided by the weight of the same volume of the hydrogen. So weight is given here as 0.24 and the weight of the same volume of hydrogen is 4.005 into 10 to the power minus 3 gram, so which is coming as 59.93. So the option for the Given question is B. Okay, dear student, let's see this question. The amount of zinc required to produce 224 ml of H2 at HTP on treatment with dilute H2SL will be. Let's see the reaction. Zn on reaction with H2SO4 gives ZnSO4 and hydrogen gas. So our aim is to know that how much amount of zinc is required to produce 224 ml of H2 gas. So we know that 1 mole of zinc is giving 1 mole of hydrogen gas. That means x ml is giving 224 ml of hydrogen. So in terms of mole, it is 224 ml into 1 mole divided by 1 mole, giving 224 ml of zinc is required. Now in terms of mass, we know that 224 ml is equals to 1 mole. So 224 ml means x mole. So x is equals to 224 ml into 1 mole divided by 224,000 ml, which is equals to mole. So it is giving 0.01 mole. Now in terms of mass will be mole into molar mass, that is 65 gram per mole, which is 65 gram. So looking onto the option is B. Okay, dear student, let's see the next question. The metal oxide has the formula Z2O3. It can be reduced by hydrogen to give free metals and water. 0.1596 gram of metal oxide requires 6 mg of hydrogen for the complete reduction. The atomic weight of the metal is. So the solution will be so Z2O3 reduced to give 2Z plus 3H2O. Here 0.1596 gram is given, and it is 0.06 gram of H2 is given. 6 mg means 0.06 gram. 1 milligram or 1 gram of hydrogen react equals to 1596 divided by 0.06, which is 26.6 gram of and the valency of metal in Z2O3 is 3. So equivalent weight of Z2O3 we got is 26.6, and therefore equivalent weight of Z plus equivalent weight of O is equals to 6. So Z plus 8 is equals to 26.6. Now value of Z is equals to 26.6 minus 8 equals to 18.6. Now atomic weight of Z is equals to 18.6 into its charge 3, that is 55.8. Since we know that equivalent weight is equals to atomic weight divided by valency, so the option is for this question is 55.8, which is option D. Okay, dear student, let's see the question. Given is Cp by Cv ratio is given 1.4 for the gas X. So what we have to find out, the number of atoms of the gas X present in 11.2 liter of its at the NTP will be. Since we know that 1 mole is equals to 6.023 into 10 to the power 23, and which is equals to 22.4 liter also. So that means if 11.2 liter is given, that means it is 0.5 mole, which is 3.01 into 10 to the power 23. So since you know that Cp by Cv, which is given 1.4, that means it is diatomic. That's why number of atom will be 2 into 3.01 into 10 to the power 23, which is 6.02 into 10 to the power 23. So option A, Cp by Cp. When I write 1.4, I said that it is diatomic. How do I know it? The value of atomicity is divided by, mentioned by its gamma, which is Cp by Cv, and that is F plus 2 R by 2 divided by F R by 2. Cp is F plus 2 R by 2 and Cb is F R by 2. So this cancel to give say F plus 2 by F, or 1 plus 2 by F. So this value will decides the values of atomicity, whether it is diatomic, whether it is triatomic, what is. So I will be referring you one table that will help you to understand about the atomicity. So let's see the type of gases. It is, let's say, monoatomic, and degree of freedom Cv, Cp and gamma, that is atomicity. So if it is monoatomic, the degree of freedom will be 3, that is 3 R by 2, and is 5 R by 2. So it is 1.67. If it is coming 1.67, that it is monoatomic. Similarly, if it is diatomic, degree of freedom will be 5, and value of Cb will be 5 R by 2, 7 R by 2. So I said that it is diatomic, no? triatomic. Triatomics are the two types. One is linear and one is non-linear. It is there. So if it is 5, then 5r by 2 it is there. The value of this one is also 1.40. And again triatomic, non-linear, it is there. The value will be 6, 8r by 2. So in this way we can able to decide the compound, whether it is diatomic, triatomic or monoatomic. Okay dear student, let's see the questions. The charge oxidation number of ABC are given here. That is, A is +2, B is +5 and C is -2. So what is the possible formula of the compound? Let's say from the option A and B and C. A2, BC, 2 and 2. 2 into 2 plus 2, 5 plus 2 into -2, 4 plus -4, it is 6. Let's see the B. B is A3, BC4, 2. 3 into 2 plus 2. B is 5 plus 4 into C is -2. 3 into 2 means is 6 plus 2, 5 plus -8, 6 plus 2 into -3, 6 equals to 0. Now let's see the C. C is A2, BC3, 2. A2, BC3, 2. 2 into 2 plus 5 plus 3 into -2, 4 plus 5 -6 plus 2 into -1, 2. So D is A3, B2, C2. 3 into 2 plus 2, 2 into 5 -2, 10 -2. So it is coming 22. So if we see the options, all this, one is giving 6, one is giving 0, one is 2 and one is 22. So the correct answer is B, because it is giving 0 at the final. So that's why correct option is B. Okay dear student, let's see the next question. The dimension of pressures are the same as that of the force per unit volume, energy per unit volume, force or energy. So we know that pressure means, we know that the pressures mean force per area. So since we know that force means mass into acceleration. Okay, so that we know that acceleration is change in velocity per unit time. So that's why our force will be mass into length. Acceleration means length and change in the velocity per unit time will be there. So length into time, and you know that area means length square. So in pressure mlt, so this will be cancelled. So this is the unit for the pressure. Now when we see for the next option, that is energy per volume. Energy means that is force into distance, and volume is there. So the unit will be mass length square per unit time, that is this one is distance, also velocity, change in velocity per unit time will be there, and the volume means length cube. So now if you see this one, energy per volume and the force per area, that is pressure, is coming same as that of the energy per volume. So that's why the option is B. Okay dear student, let's see the next question. At STP, density of CCl4 vapor in G per L will be nearest to what? And this one is very easy question. Let's see the question. We know that the 1 mole of CCl4 is 154 gram and 224 liter. So in gram per liter it will be 154 gram divided by 22.4 liter, which is coming 875 gram per liter. So the option is A. Okay, now we'll see the next question, that is what is the weight of oxygen required for the complete combustion of 2.8 kg of ethylene. So first let's carry out the equation. When you are burning any kind of hydrocarbon, it is always going to give carbon dioxide and water. After balancing, we will get this much amount of carbon dioxide and water, that is 1 mole, 3 mole, 2 mole and 2 mole. Now we know that 28 kg is given 3 into 32 kg. That means 2.8 kg means x kg. So the value of x is equals to 232 divided by, it is 10, so will be 9.6 kg. So option is C. Okay, dear student, let's see how much milli-equivalent of washing soda required to remove its hardness when there is a 12 mg of Mg2 plus is present in at least 1 liter of hard water. So let's see the equation first. Mg2 plus Na2CO3, washing soda contain Na2CO3, give MgCO3 plus 2Na plus. So you know that 1 gram equivalent is 1 gram equivalent because their amounts are same. So 1 gram equivalent of Mg2 plus equals to 12 gram of Mg2 plus, which is equals to 12,000 mg. Now 1000 milli equivalent of Na2CO3 is equals to 12,000 mg of Mg2 plus. So that means 1 milli equivalent of Na2CO3 is required for the 12 mg of Mg2 plus. So I think you got it, no? If 1000 milli equivalent of Na2CO3 is required for the 12,000 mg of Mg2 plus, means 1 milli equivalent of Na2CO3 is required for the 12 mg of Mg2 plus. So hence option will be A. 1 cc N2O NTP contains, all these options are right or not, or which of this option is right? 1 mole 54 gram liter, or you can write 22400 cc also, 6.2 into 10 to the power 23. So 1 cc means 10 to the power 23 divided by 22400 molecules. That means option B is also right. And in N2O there is 3 atoms are there. So 1 cc N2 6.02 into 10 to the power 23 400, which can be written as 1.8 into 10 to the power 23 by atoms, means option A is also right. Similarly, number of electron 7 plus 8 22. Number of electrons 6.02 into 10 to the power 23 into 22 electrons, which is going to give 1.32 by 224 into 10 to the power 23 electrons. So looking all to this, all the options are right, so option D.